All right, so yeah, that's what we're doing today. All right. No, we're not getting timed. We're getting recorded. Yeah. I hope we're getting recorded.
There's your counter.
No, usually right here there's a counter too. There's no counter there this time. I thought I could do this, but maybe. All right. So, why are we talking about these? These topics are a necessity or a necessary foundation for the algebraic techniques used throughout. It says textbook, but really we use algebra the entire year. Right? So that's why we got this. Okay? So, an equation is a statement of equality. This is math speak. So this is like stepping outside my comfort zone and actually speaking scientifically type math stuff. Okay? An equation is a statement of equality between two expressions. Now, we have a few properties of equality that we can talk about. And again, you can write these down if you want, but you don't have to because you already know all of these statements or all of these properties. The first one is the reflexive property. Okay? U is equal to U. 5 is equal to 5. 7 is equal to 14 halves. Okay, that's the reflexive property. Okay? Everything is equal to itself. Okay? That's reflexive. The symmetric property. If U is equal to V, then V is equal to U. Okay? Doesn't matter which side of the equation it's on, or which side of the equal sign it's on. They're still equal to each other. Okay? The transitive property, this is my friend's favorite one. If U equals V and V equals W, then U equals W. Okay? If 7 is equal to 14 halves, 14 halves is equal to 21 thirds. That's 7 is equal to 21 thirds. The addition. If U equals V and W equals W, then U plus W equals V plus W. So if you add the same thing on both sides, you're good. Okay? Multiplication, same thing. Multiply by the same thing on each side, it's still going to create inequality. Okay? So those are the properties of equality. You've used those since you were probably in elementary school, knowing the fact that 2 is equal to 2. Right? So we call them elbow partners. Okay? Somebody right near you. Okay? Somebody right near you. We're not talking like opposite sides of the room, but somebody right near you. So what I want you to do is I want you to come up with an answer, or I should say, come up with the completion of these two statements. Okay? So I started the sentence for you. You guys, now you and your elbow partner, come up with the completion to the statements. Okay? Both of them. Go. So a solution of the equation in X, which means that we're solving a function or we're solving an equation with a variable X, is the value is finding the value of X for which we think that it's true. So now we've got to figure out first one. Now go back to your partner or your elbow partners and find me to solve an equation in X needs to find all what are true. Okay. So what do we got here? To solve an equation in X means to find all
true solutions.
Oh, that's a lot more complicated.
But it's basically saying the exact same thing. Find all the values of X that make the equation true. Okay? So to find all the true solutions. Okay? Right? That is to find all the solutions of the equation. Okay? Love it. All right, let's do this now. Let's go back to algebra. I'm not going to do this one with you. You're going to do this one for me. Okay? So you guys do this one. I'll give you a minute to do it.
How much in church we need to run his car? Physics questions are like, how many eggs do you have? Physics questions are like,
Distribute first, yes?
Yes.
Okay. Now, if you are a combiner of the like terms, then you would have 7x minus 3 equals 5x plus 2. But if you wanted to just go directly to subtracting, so you could subtract off 5x. At the same time, you could add 3. So that's going to give you 2x equals 5. Then you got to divide by 2. And so I get x equal the 5 halves, yes?
Yes.
Yes.
How do we know we're right?
Plug it back in.
Plug it back in. Yep, exactly. With an equation, you can plug it back in. Okay. 2 times 5 halves is 5, minus 3 is 2, times 2 is 4. Okay. 5 halves times 3 is 15 halves. 5 halves plus 1, in my order of operations was, 5 halves plus 1 is 7 halves, times 3 is 21 halves. 4 is 8 halves, we're at 29 halves, and that's what we got on the other side. 5 times that is 25 halves, plus 1 more half is 29 halves. Bingo! Ooh, close that. I want to see how you guys solve this one. Love it. First step. Remember, there's like 4 different first steps here. Let's see, I told you my clock. First step, anyway.
Multiply by
We could add 2 to what?
the bottom. This one. Like you,
Not a fan of that. That's all right. I don't know what you're doing there. Okay?
Multiply both sides
By
by
8? Hey, why did you take?
because 4 fifths of the 8.
Yep. Okay? Could we have chosen another number to multiply both sides by? What? 16. Okay, there's 2. 24. Okay? On this whole 8 forward with it. Right? Like it? What would have our other option have been if we didn't want to get rid of the fraction? Yep. And turn the 2. Yep. And turn the 2 into 16 over it. So we could have gotten common denominators on all of them. Okay? We could have also, and I think this is what you were talking about, we could have combined this side into just 1 over 4. So it would have been 8 plus y over 4. I think that's what you were, while I was thinking what you were trying to say. And then we can cross multiply. Right? Okay. So we're here. So if I multiply by 8 over here, that's going to leave me with 5y minus 2. If I multiply the 8 by the 2, that's going to leave me with 16. If I multiply the y over 4 by 2, that's going to leave, or 2 by 8, that's going to leave me with y. Subtract 2y from both sides, that gives me 3y. Add 2 to both sides, that's going to give me 18. So I get y here is 6. Quick check on it. 30 minus 2 is 28. 28 divided by 8 is 7. X. 7. Okay. 2 plus 3 halves is 7 halves. Worked out. Love it. Good time. Anything else way down here? Nothing else way down there. That's a good thing. Huh? Linear inequalities. Okay? So linear inequalities are solved very similar to linear equalities. That's what we were just doing, linear equalities. Okay? So now, instead of finding just one solution or two solutions, we're finding an entire range of solutions. Okay? So we do it much the same. The only kicker is this part over here, this part right here, when we multiply or divide by a negative, we got to flip that sign. Okay? We got to flip that equality symbol. Okay? So we can first start by distributing. We can combine like terms. We can move things to either side, get numbers on one side, variables on the other. We can divide by 2. And so then that gives us negative 7 halves less than x. That's my answer. I don't flip the inequality in that case because I'm not dividing by negative 2. So the solution, so this would be the inequality. This would be the interval. This would be we can represent one of those three. We might, like if this were a test next, or in 2 weeks, right, we would probably say, give us the interval notation for the solution. Or you might say, graph the solution. Or you might say, give us the inequality for the solution. But those all three say the exact same thing. Okay? Love it. Go for it. So it sounds like everybody multiplied by 3 first. Okay? So that's going to give me then negative 9 is less than 2x plus 5 is less than or equal to positive 15. Yes? Okay, now what? Subtract 5 from where?
Everywhere.
Everywhere, yep.
The whole thing.
Just make it explode.
Yeah.
So then that's going to give me negative 14 is less than 2x is less than or equal to 10. Okay? Now what?
Divide by 2.
Divide by 2 everywhere, right? So that's going to give me negative 7 is less than x is less than or equal to 5, right? Which would be the inequality. Okay? The interval would be that, and the graph that all three. Questions, comments, concerns, clarifications, limericks.
Is there a way to check your work with like inequalities?
So with an inequality like this, so if I try a number out here on the number line, like negative 10, I should, if I put negative 10 back into this equation, I would get false state. That have negative 20 plus 5 is negative 15. Divided by 3 is negative 5. Okay? Negative 5, yes, is smaller than positive 5, but it is not bigger than negative 3. So it doesn't work out. Okay? If I try a number in the middle, like 0, 0 is the next number to try, it should be true. Okay? 0 plus 5 is 5. Divided by 3 is 5/3. And so like 1 2/3. That's bigger than a negative number because it's positive. Smaller than 5 works out. Okay? And then I gotta try a number way over here too. Okay? So like 10. Okay? So 10 times 2 is 20 plus 5 is 25. Divided by 3 is a little bit more than 8, 8 1/3. Okay? So yes, it's bigger than